this presentation, Fuad asked me to talk a little bit about what we'll be doing for deterioration modeling in the AASHTOWare bridge management software. What I plan to do is just a little background on where we were with the previous product, kind of the Weibull versus Markovian, what we're doing now, a little example, how protective systems fit in, and then what we added for NBI deterioration models also. For those of you that didn't use the PONUS 4 product, it was purely a Markovian model for the element deteriorations. And one of the things that people didn't like and didn't really match history was that with the Markovian model, it predicted a faster deterioration initially from condition state 1 to condition state 2. And so one of the things we worked on was to come up with a solution to more model reality. The other thing was the effect of protective systems wasn't really considered, or if you really looked at it from the core element standpoint, each core element may or may not have had a protective system built into it, because you might have had a bare deck, or you might have had bare deck with a thin overlay or a thick overlay, and so your protective system was built into your core element, and so it was a little more ambiguous, a little more harder to do. And in PONUS 4, you could do expert elicitation, you could do history, or you could combine both history and your expert elicitation to come up with your deterioration curves. So in 5.2.2, the release that we had that came out last year, we introduced the Weibull model for the transition from condition state 1 to condition state 2. And we hope that that would help improve people's forecasting. And let's see. And maybe just to go over just a little bit, with element ratings, you got condition states 1 through 4. And what you're trying to do is predict the transition from each condition state over time. And with the Markovian model, you're trying to predict from condition state 1 to condition state 2 how long it's going to take for 50% to transition to state 2 and 50% would remain in state 1. And that's not always easy to predict or guess. And then with the BRM 5.2.2 product, we introduced the Weibull for that transition from 1 to 2. And if you're a state that really likes Markov, you can always set your shaping factor such that you get the Markovian deterioration. So this just shows a graph showing the difference between the Markovian model and the Weibull model. This would be just from condition state 2 to condition state 1. As you can see, you have a little slower deterioration at the beginning than you do with the Markov model. And so hopefully, that'll help the states with their forecasting have a little better model. And what you can do in the software is, I know you guys can't read in the back. I sat in the back yesterday for a little bit. You can't read most of the slides anybody has, but the shaping factor you can vary, and you can do that in the software yourself. And so if you want the shaping factor 1, you get the Markovian model. Otherwise, as you increase your shaping factor, it slows the deterioration down at the beginning. But for every benefit, there's going to be a cost associated with that. And you'll notice that later on in that curve, you're going to deteriorate faster later on. And so the way the expert elicitation normally works with the Markov model is, if you got 100% of something in condition state 1, how many years is it going to take? And so we went through this effort. There was, I think there was 6 states, I think. There was South Dakota, Iowa, Michigan, Virginia, New York, Florida. And we all took our old core element data. We tried to map to the new AASHTO elements. And then Basak from Iowa, she helped us guide us through this process where we tried to come up with what we thought would be kind of a a national model we could introduce, at least in the product, that would at least allow a state to at least start off and get hopefully reasonable results. And so that's how we got the models into BRM. New Jersey, they wanted to try to create their own models, and their inspectors, they were really struggling trying to understand how long to predict 50%. And so what they did was they took a slightly different approach. They took the approach that, well, we think in 10 years, 90% of our deck will still be in condition state 1 and 10% will be in condition state 2. And so they went through an exercise trying to make some predictions with various experts, and then they backed into the transition times for the Markovian model. And so I guess the point is that there's sometimes different ways to look at your data and still get your model built. This is just a slide showing some of the variations that some of the states, Oregon, I see, I forgot that Oregon was also one of the states that participated in setting this up, but you can sometimes get quite a bit of variety in median years to transitions from state to state. But at some point you have to decide, how refined do I need my model to be? Do I need it to the exact year, or is a 5-year window good enough for predicting your network in the future and for programming? I think in this one example, Basat came up with that the standard deviation was like 8.6 for DEX. But of course, when you're looking at New York, which has probably a very aggressive environment and high traffic, is much different than Oregon or South Dakota with maybe little traffic and different environment. And so, but what we did was we just wanted to try to get a model so states had a starting point. And when you set your deteriorations up within the product, you can go into the application and just put in the transition years and whatever Weibull shaping factor that you think you need. So, and the other thing you can do is if you completely don't like the Markovian model, you don't like the Weibull and Markovian model, and you have your own equations, you can go in and write a formula for your deterioration and do that also if you want. So we try to provide quite a bit of flexibility for your element deterioration models. This is just an example of a metal bridge railing, and the yellow line is purely Markovian model, and then the others are some variations of the shaping factor, and as you can see, it maybe doesn't make a lot of difference, but it's up to each state to see how refined they think they need to be. The other thing that's a little different with the AASHTOWare elements is that they separated the protective systems from the base element. So now you have a concrete deck, which is separate from whatever protective system you might have involved with that. Same with steel girder, your painted or protective system, whether it's paint or weathering steel, are separate. And so that's another challenge that you have to try to wrestle with is some of us remember bridges being built with bare decks, and we might have an idea of how they deteriorate, but all our newer bridges are built with epoxy systems. Maybe some states are putting black down right away. So it's a little harder to predict or create your models for a bare deck because you don't really have any history of those in recent history. So that'll be a challenge for the states. But what you can do now is with the protective systems is you can add a factor that's going to protect your base element, and there's an effectiveness depending on which condition state your protective system is in. And out of the box, what's going to come for the states is if your protective system is in condition state 1 that's fully effective, so you get 100% of your protection factor. If you're in condition state 4, by definition, that's failed, so you have 0% effectiveness. And if you're in condition state 2 and 3, that's where the states have to make the determination of what they feel their protection factor is going to be in those condition states. And for each of the protective systems, there's right here, there's whatever your protection factor is. In this case, it's saying 1.41. It's going to slow your curve down by a factor of 1.41. So instead of deteriorating maybe 10 years, it's going to be 14.1 years to deteriorate if it's in condition state 1. And then in this case, if your wearing surface is in condition state 2, it's 0.67. If it's in condition state 3, it's 0.33. You take that factor times your protection factor, and it's going to slow down that. It's not going to be as effective as a fully effective. The other thing that we added into the product kind of late, we had never anticipated needing to do this, was because everything moving forward was elements, elements, elements. And then, of course, MAP 21 came along and said, structurally deficient, you have to be less than 10% on your NHS. Now all of a sudden, states are going to have a target, performance measure, whatever you want to call it, that's NBI related, and we had never really anticipated really having to track NBI like we used to. One of the things Federal Highway did do is they came up with a converter similar to the translator that we had with the core elements, except this was going to work both ways. You could take NBI data and get a fuzzy element distribution, or you could take your element data and it'd predict your NBI values. And this is just an example from Federal Highway that of how, depending on how much condition state you have and what quantity in each condition state, what the equivalent NBI would be. And of course, when you start aggregating different elements of a superstructure or a substructure, how much weight do you put on bearings versus a cap versus a column, how many columns you have. It gets kind of complicated to come up with an equivalent NBI rating. And so we've come up with a couple different ways in the product. But we did a couple different ways where you could weight the different substructure elements, in this case with columns, walls, abutments. And you can assign a relative weight to each of those elements. And then as you come across, you take your health index of each of those elements. So it's kind of a sub-health index. And then you come up with what the NBI conversion is for each individual element. And then based on the weights, you come up with an equivalent NBI conversion. But it's nothing wonderful or magical. It's kind of ugly, but it does give you kind of a rough idea of plus or minus 1 of what your NBI ratings would be based on your elements. It's just really hard to take very refined element data and create a generic NBI rating because NBI is just kind of a general rating. It gives you an overall idea of what your bridge is, where the elements are very detailed. So we have a table for each of your NBI elements or NBI ratings, and you can put in the number of years to transition from 9 to 8, 8 to 7. And then what we did was we created a tool that it gives you your distribution. You can filter either on your whole network or whatever group of bridges you want to look at, state, local. And then you can, in this case, it was deck. And so this is the current distribution based on the latest NBI rating for each bridge. And then based on the transitions that you set up, it predicts, it'll tell you where you'd be today and in 5 years, and in 10 years based on your transition probability. So you can really quickly see with your inventory what those transition times do. And so you can play around with that. And it works really slick to kind of give you a real rough idea of how your inventory or group of bridges are going to transition. So without getting too into the weeds on things, kind of is the approach we're taking, and Rob's going to be talking about how long-term bridge is doing that. And I know one of the things FWAD wanted us to try to do is how can states, leverage upon each other? How can the states and long-term bridge either work together or complement each other? And I think there's probably a lot of opportunities to do that moving forward. And so.
Hey, Tom. I was looking at those shapes and distributions and, the models that you have. Between the Markov and the Weibull, is Weibull more appropriate for this, considering that, the shape pretty much, you can define the shape factors the way you want.
Right.
Would Weibull be more appropriate for this infrastructure deterioration?
Yeah, we did some, it was probably 6 years ago, we did some research, and Paul Thompson came up with, and he did a white paper for us that he thought for bridge structures that the Weibull was probably appropriate for your condition state 1 to 2 transition, and then the Markov after that. So, so that's the approach we took, was based on some of Paul Thompson's research.
Is the AASHTOWare trying to do that, using Weibull for the part of the transition and then using Markov later, or just pick one or the other?
Well, the way we have it customized is you set the shaping factor for the Weibull transition from 1 to 2. Mm-hmm. But if you don't like Weibull and you want Markov, you can just set your shaping factor to 1.
Got it.
So it's customizable by the agency of how they want to do that.
Okay.
And if they don't like any of the options we provided, we gave them the ability to write a formula for their transition. So. Got it.
Yeah, I saw that. One other question I have, you had indicated a data where the standard deviation is about 52% of the average. Do you remember that? Yeah. From Prasad or something?
Yep, yeah, Prasad kind of worked through the data as all of our states kind of work together.
That's a significant scatter in the data, isn't it?
Yep.
Okay.
But it gives you a pretty good idea. I mean, like if you looked at that one example, I mean, New York expected their decks to transition from condition state 1 to 2 in like 6 years, and Florida was like 27 years. Well, obviously New York and Florida are, if we'd look at substructure, Florida would probably be pretty fast for some of their areas where their decks, it's kind of like Texas. I mean, there is no management system needed for decks in Texas because nothing happens. But
yeah, Florida substructures are about 7 years.
Right, and I think Basak did try to, if there were some real big outliers when she was processing our data, she would try to exclude some of those that were very extreme or very conservative. But we needed something to start with for the states, and no matter.
With that scatter, you'd be completely off, right?
Yeah, and so. But it was a starting point anyway, so.
Thank you.
So for the state, which is they don't have, say, a lot of element inspection cycles, how is that going to work for them? And would BRM have, say, the conversion you talked about, which is they do probably have NBI historical data?
Right.
Is that a conversion inside the BRM, or they have to go through somebody, or they get their own? Or what do you think?
I think there's a lot of, the actual limits have only been required to be collected for the last 2 years, and only required on the NHS. And so, so clearly you need the ability to look at both. And a lot of states had good core element data. A lot of states had, 20 years of core element data. Of course, that kind of, I won't say it all went out the window, but some of the elements do map very nicely. Some of the 4 condition states to 4 condition states, those all mapped 1-to-1 most of the time. So there your core element data could help you. Some of the others is a little harder. If we got time for one more question, or
So this only predicts NBI condition ratings or whatever you're looking at out into the future? Is that
You can do either. You can predict either element or MBI.
okay? And this is just from a local system that has 20,000 bridges and no, I mean, the last time they were load rated was back in about the 1990s. I'm not saying this would be a, yeah, people are turning around going, what? Could you also use this to not establish what your legal load rating value would be, but to also predict a rough ballpark load rating, how they're going to deteriorate over time as well?
Not sure, I guess I have to think about that.
I'm not saying to be used as a legal load rating, but just to show
Yeah.
owners that this is how your bridge is going to deteriorate in.
Yeah, I'm not sure offhand, but
Well, it would be a useful tool.
you had me when you said you hadn't load rated the bridges since the 90s, and but
Well, here's what the point I'm trying to make is if it has a current load rating of 20 tons, just say a single truck, a single posting, 20 tons. If it's load rating at 25 tons right now, and you can show an owner that based on deterioration in this model that's established by states, that it should load rate at about 15 tons right now, it would be very useful to take that to them and be able to say, you need to reload rate this bridge.
yeah, I'm not sure how you could do that, because if it's the deck that's deteriorating, is it the substructures? This,
It'd be a weighted average of
be hard to.
all of them.
Yeah,
But anyway, I was just curious.
I'd defer that to the long-term bridge folks to research that.
Thank you very much, Dad. Appreciate it.